Hello, my beautiful computer science students. Welcome to another lesson in our unit on selection and iteration. If you're new here, I am Goldie and I'm here to take you through everything in AP CSA and as it relates to our course. So today we are going to be going through lesson 3, compound Boolean expressions. And this is a pretty chunky lesson, so I hope you're ready to kind of buckle in and get ready here. We're going to talk about our compound Boolean expressions, but we're also going to be talking about comparing Boolean expressions. So I'm going to introduce some new ideas, but there's a lot of examples that are kind of woven in throughout this lesson to help start you getting comfortable with this material. So get settled in, get ready to take some notes, and let's go through everything together. So checking two conditions, we kind of introduced this idea in our last lesson, and we have a way where we can check two conditions, but we're going to learn another way today, right? So if I originally tell you, let's check to see if a number X is between 20 and 30 exclusively, okay? So including the endpoints, right? Now, the way Java evaluates expressions, it can only answer one comparison operator at a time. It can't compute compound comparison expressions, like expressions that you might be used to in algebra. So again, checking if a number X is between 20 and 30 exclusively, excluding the endpoints, right? I don't know if I misspoke earlier, but excluding the endpoints, you can't write something like this. You can't say if 20 is greater than, if X is greater than 20 but less than 30, print between 20 and 30, right? This is an incorrect syntax. You'll get a compiler error. It can't do this. Another correct way to do this would be what we learned about in last lesson, which would be to use nested conditionals. So if X is greater than 20, your next step is to check if X is less than 30. And if it is, then you can print X is between 20 and 30, or print between 20 and 30. That would be the correct way of using nested conditionals to check two comparison expressions. Another way is to use what we call a Boolean operator. And it's created to overcome this deficiency of only being able to ask one comparison operator at a time. Boolean operators allow us to compare multiple Boolean expressions. And remember, a Boolean expression evaluates to true or false. So it could be like an expression we just saw where X was greater than 20. That is a Boolean expression because that evaluates to true or false. It could also just be a Boolean variable because a Boolean variable is true or false by nature, okay? But a Boolean operator allows us to compare them, compare however many true, false values to see what we get. Now there's 3 Boolean operators we're going to be talking about: and, or, and not. Okay, so the first one, and. The symbol in Java is the double ampersand. Okay, so the double ampersand, it's above the 7 on a keyboard, right? And this Boolean operator evaluates to true only if both of the what we call conditions or both of the expressions are true. Okay. Now, a lot of the times to evaluate a Boolean operator, we use what's called a truth table. And a truth table is just a tool that we use to evaluate these, a way to organize our values, our true and falses, and it allows us to evaluate our expression. So the way a truth table is set up, because we're going to be making quite a bit of truth tables here, is we start with 2 variables. I'm going to call them A and B. They can be called whatever, X, Y, just whatever, okay? A and B is what I'm going to start off with. And what we do is we write down all of the combinations of true and false we can have with A and B. So if A and B are 2 Boolean values or 2 Boolean comparison values, whatever they are, they evaluate to true and false. Okay, I'm going to write down all possible combinations. If I could have A be true and B be true, A be true, B be false, A be false, B be true, A is false, B is false. Okay, those are all the combinations that I can have. And I start with that in my truth table. And then I put down in the next column what my Boolean operator is. And this is the simple one of A and B. Okay, so we pronounce that A and B. And what does it evaluate to? Well, it only evaluates to true if both conditions are true. So for this first line, A is true, B is true. So A and B are going to evaluate to true. Okay. Everything else is going to evaluate to false because they're both not true. Okay. A and B will only evaluate to true if both of them on either side, is sometimes what we say, either side is true. Both have to be true. Okay. So if I want to write an if statement to determine if X is between 20 and 30, and I want to use this Boolean operator, I could write something like this. If X is greater than 20 and X is less than 30. Okay. So I put a Boolean operator between them, and that allows me, so this is going to evaluate to true or false, depending on the value of X, right? And this is going to evaluate to true or false. Okay. So those comparisons happen, and then I use this, okay? If this evaluates to true, the only time it evaluates to true is if both of these expressions evaluate to true. And that would then tell us, hey, if X is greater than 20 and X is less than 30, that means that X is between 20 and 30. Make sense? Now, this looks a little weird, this whole expression, because I'm introducing a lot right now. We're going to talk about order precedence in a couple slides in a little bit later on. But order precedence, the comparisons happen first. Okay, the Boolean operator does happen last. So fun fact, little spoiler, but we'll get to order precedence. But that's and. The next Boolean operator is or. Okay, and the symbol here is the double vertical bar. Now the double vertical bar is on your keyboard. It's right above the, I want to call that a forward slash. I'm so bad with my forward slash versus backslash. I never know which one is which, but it's right above, I want to say it's the forward slash. Maybe it's the backslash. I don't know. Right above the slash, which is right above the enter key on your keyboard. Okay, but it's two vertical bars make up the symbol or. Now, this will evaluate to true if one or both statements are true. So as long as one or both of them are true, it's going to evaluate to true. So I'm going to set up my truth table again with all combinations of A and B, true or false. And then I'm going to evaluate. And what's going to happen is these values are going to be true because here both are true. Here only one is true. Here only one is true. But it always evaluates to true. Okay. Here both are false. And this is going to evaluate to false now. Okay. So an example of this, write an if statement to determine if X is greater than 18 or less than or equal to 21. Okay. So I'm going to take this and turn it into Java code. Okay. You remember in math, you know, when you're first learning about problem solving and it would tell you to take the words and then change them into math symbols? That's almost what we're doing. If, and then X is greater than, so if X is greater than 18, or boop, boop, X is less than or equal to 21, then I want to do something with it, right? There it is, right? Just in words, I was able to write my Java code. It's beautiful. It's truly beautiful. That's my or. My last Boolean operator that we're going to do in this class is not. Okay? Not is just an exclamation point, and all it does is switches the Boolean value. We have seen not already when we talk about not equal to, right? So we have equal to check if two things are equal, and then we have not equal to. It's similar because it's also not, but it works differently when it's used in combination with a Boolean value, okay? So yes, this is not equal to, but it's a separate symbol from just the not symbol, okay? So setting up my truth table, if A is true, true, false, false, then not A would be false, false, true, true. Okay? It switches the Boolean value. So vice versa, if B was true, false, not B would be false, true, false, true. Okay. So here, if I have this statement, what does the following if statement ask? Okay. So if not age greater than 18 or not age less than 21. Okay. What is that saying? It's saying if your age is not greater than 18 and not less than or equal to 21, then you're going to do something. Okay? So not greater than 18, not less than or equal to 21. Okay? And it's going to switch that value, switch that Boolean. We're going to see how that plays out in expressions here in a moment, okay? We're going to see how that plays out. But that's an introduction into it. Okay. Truth tables. Yes. Look at this beautiful thing. So this is a bit of a more full truth table. Truth tables are very helpful for organizing our Boolean values. They also help us answer these questions about which expressions are equivalent and to work out more complicated Boolean expressions. So you can see how our last line here is crazy, right? If I said, hey, evaluate this expression, you'd be like, Goldie, I'm not doing that, right? If I just showed you this, but you will if you remember that you can use the truth table to help you, okay? So we're going to build to that. Excuse me. So to build to it, we're going to make our truth table. Now, the way we set up our truth table in order to build to this, because I want to know, what is this? This is our goal. This is our final goal. I always start off with X and Y and all the different combinations, right? I could have them both be true, true, false, false, true, false, false. Start with that. And then if I know I have to build to this, what am I building to here? Okay, I'm building up here. I'm going to break it down. I have this expression right here, or not Y. Okay, we haven't quite talked about order precedence yet, but it'll make sense when we play around with it. So first I have this or statement. So I'm going to evaluate this. See how these are equivalent right here, what I circled here. And then this one I have over here. Okay. Now I need to break down this statement a little bit more. I have just my regular X, which is right here. And I have this crazy expression, which I broke down right here. Now I'm going to break down this crazy expression because this is a not in front of this expression. And this expression is right here. And then I'm going to break down this crazy expression. It's X or not Y. Well, X is going to be here again. Not Y is going to be right here. Okay. So all of these I'm going to break down and I'm going to build up by evaluating this expression through my truth table. Okay. Now this I just kind of threw in for fun. We're going to do that. I don't expect you to break these down right now. We haven't talked about order precedence. We've barely practiced these. Okay. I just want to show you like, hey, this is why we're using truth tables, is eventually we can break down these complicated expressions into smaller pieces that we're able to kind of evaluate through with a truth table. Okay. That's the end goal. But we haven't even talked about order precedence yet. So I don't want you stressing about this. At this stage, what I want to show you right now, my goal is to show you how to evaluate these Boolean expressions. So for instance, if I start with here, how do I just evaluate something like not X? Okay. Well, not X is just switching the logic of X over here. So X is true, not X would be false. If X is true, not X would be false. False turns to true. False turns to true. Okay. Now let's take it a step further. Let's look at not X and Y. Okay. Now when I use this, I start with these, what columns you already have of these two values. So not X is right here, and then Y is right here. So I'm going to use these two columns and compare them with an and. Okay, now remember, and evaluates to true only if both are true. Okay, so where are they both true? Well, they're both true right here. Okay, so this should evaluate to true because they're both true right there. Everywhere else, one or both of them are false. So everywhere else, we should have a false. Okay. Now what I have on the slides is I'm going to take the two values, I'm going to put them in the box so you can see. So not X is false. Y is true here, which we said is going to evaluate to false. False and false evaluates to false. True and true, that's where you evaluate to true. True and false evaluates to false. Okay? Now let's look at not Y. Not Y is just taking this and switching the logic. So we get false, true, true. Now when I'm comparing X or not Y, I'm going to use my comparison operator here, or, and I'm going to use this column and this column right here. Had to look at the columns. Okay. Now we're looking at or. So remember, or is true when one or both are true. Okay. So in this situation, one of them is true. Here, both are true. Here, both are false. So this is going to be false. And here, one of them is true. Okay. So that's what you're going to get. I'm going to show these with like the true false values, almost not plugged in, but kind of plugged in, right? With symbols, symbolically plugged in, right? True or true will be true. False or false, that's when it evaluates to false. False or true will evaluate to true. Okay. Then when we have these more complicated expressions, notice how in here, that's just this column, right? But I have this not operator in front. And that not operator is what is going to switch my logic on it, right? So I'm going to have that column, but I'm just going to switch the logic. Okay. So I'm going to have this true, true, false, true, and I just switch the logic. So it's going to be false, false, true, false. Not true, false, false, true, false. Look good? Now we're building here because I already have this column's made. This column is made, okay, right? She's beautiful. And I'm going to compare it with this column right here. Also beautiful. And I'm going to use the and to compare them, okay? So I have true and false, that's going to be false. I have true and false, that's going to be false. I have false and true, that's going to be false. And I have false and false, which is also going to be false. So that whole column is false. Interesting, huh? Everything's false. And then my last one. Okay, again, I already have this one. This one's already made. Okay, I already have this column. So I'm going to use that column and I'm going to have this. Now, the reason why this column's already made is because not only did I do the parentheses first in order of precedence, but the and actually has higher precedence than the or. Okay, so the and will get evaluated first before the or. So that's why it's good and correct that I have this already evaluated first. That's just this column right here, which was all false. The not Y was this column right here. So I'm going to compare these two columns with the or. Okay. So false or false will be false. True or false is true. False or false is false. True or false is true. Okay. So if I go through all of those, that's going to be my result. Okay. Goldie, that was crazy. And I know it was crazy. This is one of the foundational topics when it comes to programming logic, okay, is being able to evaluate these expressions. Will you have to do this when you actually code? Maybe, okay, maybe not in this class, but you might, okay. But more importantly, it helps build these critical thinking skills, which you need. And it helps you to use a truth table, which is a tool you'll also need to help evaluate complicated Boolean expressions. Now, we don't always use a truth table for all of these, okay? We will use a truth table for situations like we just had, but some examples, which I'm going to show you and I'm going to get to here in a moment, you don't need a truth table for, you just evaluate the expression as it is. Okay. So let's talk about order precedence here. Here is a table, an order precedence table. When we talk about order precedence, it determines the order in which parts of an expression are evaluated in Java. Okay. For the most part, it follows order of operations that you know, but of course there's a lot more symbols in Java that have been added. Okay, so here's the order precedence with just talking about the stuff that we've gone over. If you look at an order precedence table online for Java, it's going to be much larger because there's actually a lot more symbols, not a ton more, but there's a couple more symbols that are out there in Java that we don't use in this course, okay? But these are all of the symbols that we use. So it starts off as the grouping symbols first, which is just parentheses, right? And then we get into unary, what we call unary operators. So unary operators are the ones that go right in front. So this would be the increment or the decrement, the compound operators there. Positive or negative symbols. The not operator, the logical not, goes here. And also typecasting goes here, okay? Now remember that grouping symbols go first. So if any of these are outside of grouping symbols, the grouping symbols need to go first. Okay. After these, we have the arithmetic operators. So multiplicative ones, the multiply, divide, and mod, come before the additive ones, the plus and the minus. Okay. Comparison operators happen next. First relational and then equality. And then the last thing is the Boolean operators. The and has precedence over the or. Okay, so notice the relational and the equality, and then the and the or. Okay. Now within these, okay, like the relational operators, all of those have the same precedence. So they're evaluated from left to right. Kind of like how if you run into addition and subtraction in the same expression, you evaluate from left to right. Okay, same kind of thing here. Remember, parentheses always have the highest order precedence. So you can use them to override any of these orders here. Okay. So if you're coding something, just use parentheses, especially if you have some longer expressions that you're using comparison for. Sometimes when you're looking at code, it's hard to remember, what comes first, the and or the or, when you're not used to it. If you need to add in parentheses just to help you even just visualize what comes first, even if order precedence is going to take hold, you do it. Okay, I want you to do it. Overuse parentheses if you need to. Okay, so the arithmetic ones, comparisons, then Booleans, within those types, there's different precedences. Okay, so just know that. Okay, again, left to right. Unary operators are right to left because you start with the value and then the unary is on the left, and it happens like you think it would happen. The assignment operator does technically have the lowest precedence. So when you have an assignment occurring, it always occurs last. Okay. If you have a compound, if you use a compound assignment, that always happens last, right? So if you had x plus equals 2 plus 3 times 4, this would get evaluated first, then the x gets added to this 14, and then it gets stored back in x, okay? So assignment and compound assignments happen at the very end. Okay. Even though they're not included in this table, they happen at the very end. Okay. All right, let's look at some examples. Okay, let's look at here are some different examples of things you might see on the AP exam asking you to evaluate, or things that might just naturally come up as you code your program too. So what do the following statements evaluate to? I got a couple of examples here. So this has X being true, Y equals false, and Z equals false. So it has 3 Boolean variables. And what do the statements evaluate to? So I have this here. Now, with this, you can kind of see, oh, maybe I should use a truth table. But this has set values for X, Y, and Z. You're not looking at all combinations. You don't need to look at all combinations of X, Y, and Z. They have their values. And because of that, it's like a substitution problem. X is true, Y is false, and Z is false. So you can take TFF, again, just as stand-in values to evaluate it, and substitute them in order to evaluate the expression. Okay? Because now I would evaluate this first. Okay? And in fact, this is a good example of if you had this, okay, or an and, the and already gets evaluated first, okay, whether there's parentheses or not. But here I have parentheses, okay, and it just helps. You didn't even have to remember, oh yeah, and comes before or. Because I put parentheses in there, you just naturally know, oh, I have to do the parentheses first, right? So that's what I mean by overuse parentheses. If you see something like that, or you need to code something like that, just use parentheses to help you evaluate it, okay? If you don't remember that the and comes first. Although you should by the end of this unit, that and comes first, but I digress. F and F, what does that evaluate to? If we have 2 falses, what does the and evaluate to? That will evaluate to false. Okay, so we simplify that, and then we're left with the expression true or false, which evaluates to true. Okay, so that expression, that statement, is going to evaluate to true. Here's another example. Pause and try it on your own if you would like to. I'm going to go through the answer here. Again, I'm kind of quote unquote substituting in values here. T for X, F for Y. What gets evaluated first? It's always parentheses. Always parentheses here. True and false will evaluate to false here. Okay, then we have not false and not false. Okay, now the unary comes next, so I have to do the not false. Not false would be true and true, switches them. True and true will evaluate to true. And then the last one here, again, substitute in the values in order to evaluate it. And then when I'm looking at this, what on earth do I do first here? You have multiple grouping, always grouping symbols, right? And you have multiple ones. Just like math class, do the inner ones first. So I'm going to do these ones first. False or false evaluates to false. Okay, so this got changed to this. Okay, so I have parentheses again, but inside parentheses I have the or and the and. What gets evaluated first? The and does. Okay, so you're going to do the and. And false evaluates to false. Okay. And still in parentheses, the or gets evaluated next. Okay. Or false is false still. And then last I have the unary operator, not false is true. Okay. So you might be asked just to kind of evaluate simple Boolean expressions like that. Okay. And in which case, when you have set values, you don't need to make a truth table for. Okay. Now let's talk about negating comparison operators. Okay, this is going to lead to a couple more things we get to talk about later on. But negating a comparison operator involves switching the comparison operator to the exact opposite operator. And the way I like to show you this is with a number line. Right? So if I asked you to graph x greater than 4, and you were in algebra class and you had to graph x greater than 4 on the number line, you would do an open circle on 4 and then shade everything to the right, because that is how we represent, visually, how we represent x greater than 4, all the values greater than 4. Now, if I asked you to graph not x greater than 4, okay, not x greater than 4, you are negating, you are doing the exact opposite of that. So what's the exact opposite of this visually? The exact opposite would be shading in the 4 and then shading the other way on the number line, right? That would be the exact opposite. So visually you see how those are direct opposites. And that's also what I have in my expression here. I have x greater than 4, not x greater than 4. But what's another way I can write this with my Java operators? Well, I can write that as x less than or equal to 4. Okay. And this right here, going from this to this, is what we're talking about when we say negating a comparison operator. When we negate Boolean values, right, we switch it. It's like a light switch, right? If it's not false, then it's true. When we negate comparison operators, we're doing the same thing. We're switching it to the exact opposite. But switching it to the opposite is a little bit more complicated than just going back and forth between true and false. Okay. Visually, this is what we're doing. Let's look at it in code. So if I say not x less than or equal to 4, what is that logically equivalent to? It's going to be x greater than 4. Okay. So you're going to switch the direction of that comparison, and if it has an equal, you're going to get rid of it. If it doesn't have an equal, like this next one, then you're going to put it in. Oh, I guess we're going off to the side. Okay. So if it has an equal, I got rid of it and I switched it. If it has an equal, I got rid of it. If it doesn't have an equal, I added it in and I switched it. It doesn't have an equal, I added it in and I switched it. Okay. So remember what this is saying, not x greater than 4 is the example we just did, is the equivalent of saying x is less than or equal to 4. It's just I didn't draw a number line with each of these. Not x equal to 4 is equivalent to saying x is not equal to 4. And then the equivalent of not equal to is just saying x is equal to 4. Remember how two negatives make a positive? It's true in English and also in math. Two negatives make a positive. Okay, saying not twice makes, yeah, here we go. We're cross-curricular here, y'all. Okay. Here's where that's going to come up. Evaluate the following expressions, okay? Because you might code it, yes, but the logic behind it is very important for you to know, okay? So evaluate these expressions. Let's see what some of these expressions are occurring here. Now, I put the parentheses in for organization's sake. Relational operators, like the greater than, less than, not equal to, all of those happen before the Boolean operators. So if I didn't have parentheses here in this expression, it would evaluate the same, okay? But notice how the parentheses do make things just visually easier to kind of group together. Okay, so if you got to overuse parentheses, okay? So what's going to happen here? If I want to evaluate, I have 3 comparisons that need to happen first. Now, comparisons evaluate to true or false. So is 2 less than 3? That's going to be true. Is 4 not equal to 5? That's going to be true. Is 6 greater than or equal to 13? That's going to be false. So all of those comparisons happen. And now I get to evaluate my Booleans. So what comes first, the and or the or? Well, the and happens first. True and true evaluates to true. And then I have true or false evaluates to true. Okay. here is another situation. Okay. Now, with these situations, again, when you're involving just numbers, I recommend getting to true and false values just as quick as you can, right? So if I have not 3 less than 4, okay, what we just covered, we know that not 3 less than 4 is the same as saying 3 greater than or equal to 4, okay, which is false, right? 3 is not greater than or equal to 4. Over here, if I would have said, okay, not, let me evaluate, what is 3 less than 4? 3 less than 4 is true, okay? Not true is false, okay? Now you see how the outcome of that little mini expression was the same. They both evaluated to false. It's just the way I got there, it just depends, it kind of depends on you. Do you like simplifying it this way? Or do you like simplifying it this way over here? Okay. Again, up to you. I personally like evaluating it like this over here. Oops, that's not a star at all. Sorry, I wrote that. I like evaluating that right there. But you can do either because you're going to get the same answer. So let's look at it here. I said 3 less than 4 is true. 5 greater than or equal to 10 is false. And 3 not equal to 3 is also false. Okay. So I evaluated those first as true or false statements. Okay. Next, I do the unary operators. So I'm going to switch those into false, and not false is true. Okay. So you can see the switch happen there and the switch happen there. Next, the and takes precedence, so true and false evaluates to false. False or false will evaluate to false. Okay. Yeah. Okay. So a couple of examples. Here's some other examples. Same situation as our last expressions, except now we have to deal with substituting in numbers, and we have to deal with a little bit of operations in there too, okay, just to make things fun. When you're looking at what the statements evaluate to, kind of like how your Booleans we substituted in values, I recommend doing the same thing here and substitute in the values so that you can evaluate what this evaluates to. Num1 is 3, num2 is going to be 8, and num3 is 24. So put those values in. Look at this greatness. Okay, we got a lot going on. There's no parentheses. Notice how you have comparison. You have a Boolean operator. You have an operator and another comparison. Remember your precedence. Okay, what comes first? Operators come first. Next comes the relationals, and then comes the Booleans. Okay. Operators first. Where's my operator? Here's my operator. This is what I do first. Operators, all operators first. Okay. 24 mod 8 is 0. Why? Because 8 divides evenly into 24. Okay. So that's 0. Okay. Now remember, 0, it's a number. 0 doesn't mean it just goes away. Okay. You got to remember to put 0 in there. Next, I do relationals. Now, relationals, my greater than, equal to, less than, or equal to, that happened before my equal to. Luckily, it's from left to right too, so hopefully that doesn't throw you off too much. But this is going to happen next. Okay, this gets evaluated. And remember, whereas operators evaluate to a number, comparisons and Booleans both evaluate to true or false. So 3 less than 24, I'm not solving that in any sort of numerical sense. I'm asking a question. Is 3 less than 24? That is true. Okay, that is true. So that happens. That's true. And then I have my and then I have my relational over here. Is 0 equal to 1? That's false. So that's how I get true and false here. And then my last step is to do that Boolean operator that will evaluate to false. Okay. Oh, here's another exciting one. Again, notice my overuse of parentheses. I technically don't need parentheses here, but they help group things together in a nice, pretty way. Plug those numbers in. Okay. Now, what do? I see the grouping symbols, so I'll start over here, and I have an operator, and I have a relational. Do the operator first. Okay, same thing here. I have an operator and then relational. Do the operator first. 3 times 8 is 24, and then over here, 24 minus 12 is 12. So I did my operators. Now I can do my relational inside my parentheses here. So I'm going to evaluate each of these. Okay. 24 less than or equal to 24 is true. 12 greater than or equal to 10 is also true. Then I have my unary right in front. Not true is false. False or true evaluates to true. Okay. So exciting. So exciting. Okay. Now let's shift gears. Now that we've kind of evaluated expressions, we've learned about Boolean operators, we've learned about truth tables, let's talk short circuit evaluation. Okay. Now, short circuit evaluation is a concept where the compiler will actually skip logical expressions in a Boolean when it knows what the logical outcome will be. And some of you have probably already kind of seen this, especially if you're familiar with Boolean operators. So let's say I have two expressions that I'm comparing with an and statement. Okay. Now, expression 1 will get evaluated first. Now, if Java knows expression 1 is false, logically, the whole expression will evaluate to false no matter what is expression 2, right? As soon as there's a false statement in an and, the whole thing is false. Because of this, the compiler will not actually check expression 2. And that's what short circuit means. It means the circuit that it has, it evaluates the shorter piece first. And if it already knows that, hey, this is false because it's an and statement, the whole thing will be false. Okay? Short circuit. Shortens the evaluation. For an or, okay, what happens with an or? Well, if expression 3, which gets evaluated first, if it determines that that's true, then logically the whole expression will be true, no matter what expression 4 is, right? Because as soon as there's a true statement in there, the whole thing is true. Okay, and because of this, the compiler will actually not check expression 4. It'll say, you know what, the whole thing is true. I don't need to check expression 4 to know that. Okay. Now, why is this relevant? Well, it's not super relevant in what we do in this class. The one example I was able to think of here, how we might be able to take advantage of short circuiting, is to help us with avoiding runtime errors. Okay. So instead of having to catch and throw exceptions, we can kind of handle it in the form of short circuit. Okay? What does that even mean? Okay? Well, it says if x is not equal to 0 and y divided by x is equal to 2, then we say x is half of y. Okay? Now, why would this be a way of taking advantage of short circuiting? Okay? Well, this expression right here, because it involves dividing by x, if x is 0, when I go to divide by it, I'm going to get a runtime error. An arithmetic exception is going to be thrown if x is 0. Okay? So I don't want that to run if x is 0. Okay? So I have this statement right here. As long as x is not equal to 0, then I want Java to run this statement. Okay? If x is equal to 0, this becomes false. And because of the and, then this is never run. Okay? So do you see that? If this is false, this is and, Java says, hey, it doesn't matter what happens here. I already know the whole thing is going to be false. So if it's false, this is never run, and I've avoided dividing by 0. Okay? And if I avoid dividing by 0, then I avoid that runtime error. Okay? And I avoided a runtime error without having to use any sort of exceptions handling, okay? Which we don't know how to do yet. So, okay. So that would be an advantage of how in this class we could take advantage of that short circuit. Okay. Otherwise, just know it. Just know it. It's a logical fact that you can know. okay? The next thing, shifting gears a little bit, is DeMorgan's law. So there's two quote unquote laws. They're more just kind of properties that help us evaluate complicated Boolean expressions. So knowing these laws, you got to know them for the course, but knowing them is also going to help you evaluate longer Boolean expressions, okay? These laws actually do pop up in many math classes, in fact, especially some of the logic ones that you run into in college. So it's actually kind of interesting. But we're going to apply them to our Boolean expressions. So before we actually get to what the laws are, though, I want to go back to truth tables, and I want to show you kind of an informal proof of these statements these laws I'm about to tell you. Okay, so let's look at this truth table here. We're going to evaluate it. So I start off with A and B, again, the different combinations of it, and we're going to evaluate each of these columns. So the A or B, okay? A or B evaluates to true, 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 false. Not A or B switches that logic into false, 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 true. Right? With me so far? Let me switch up A. So A is true, true, false, false. False, false, true, true. Let me switch up B. Okay. B goes from true, false to false, true, false, true. And then now when I look at not A and not B, okay, I'm comparing these two. Okay. I'm comparing those two columns right here. So not true, false, 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 true. Now, why did I do that? Besides just to practice. Well, I want you to notice these two columns right here. These two columns have the same output. Logically, they are the same for all values of A and B. And that's DeMorgan's first law, okay, is that these are going to be equivalent for all values of A and B. Doesn't matter what values of A and B are, these two statements are equal to each other. Okay. Fun fact. I know. You're like, how does this even help me? What is this even? Right? What is this even? Well, I hesitate to say this, but some teachers refer to this as the distributive law of Boolean operators. Now, I say this just to kind of get you used to what this is doing for us. I don't want you to think of this as distributing. So when you see this not symbol in front of this, okay, what you're taught, when you're in math class, right, is if you have 2 in front of x plus 3 to distribute the 2, right, and you get 2x plus 6. Perfect. That works well in math class. And a lot of the time students want to do that here. Okay, and that's sort of visually what we're doing. We're not quite doing that logically, okay? So just think of it, distribute as a visual sense, not as an actual sense, and you'll see that come up. But you give that negation to each of these, and then you switch the Boolean operator, okay? And you're going to see that same kind of pattern for the second DeMorgan law. Okay, so for the second DeMorgan law, we got A and B in this truth table. Not A or B, we're going to switch that logic. We got not A, not B. Okay, sorry, pause the video if I'm going too fast. And then in this last one, we're going to compare these two, okay, with the or statement. False, true, true, true. Okay, false because these are both false, and then the rest of these are true. Okay. And you can probably see where this is going. You see these two columns are logically equivalent for all values of A and B. And again, you can kind of see how visually we're giving it to both A and B, and then we're switching this Boolean operator here, okay? Again, I hesitate to call it distributive, okay, for a few different logic reasons, but if it helps you learn DeMorgan's laws, just think of it as that. It's a visual way to kind of remember it, but don't think of it as the distributive property. It's just a visual way to help you remember these laws. Okay. Now, the way they can be useful are going to be for some of these multiple choice problems you're going to run into. Okay. So this is tested heavily in the multiple choice section of the AP exam in something like this. Which of the following is the same as the code below? So this just straight tests you on it, right? So this is saying you have two comparisons here, and you want to know which of these expressions is the same. Okay, so you can see how the choices, the negation is gone. So that means you got to kind of give it to both. This is a direct use of DeMorgan's law. Give it to both, and then switch this logic sign here. So I can already tell you that B and D are not it because it never even switched the logic sign. Okay. But this is where negating comparisons does come in, because you got to be able to negate these comparisons. So if I were to negate x less than or equal to 4, okay, that's directly switching the sign. And since it had an equal sign there, I'm not going to include it here. And then here, negating the not equals means making it into equals. Okay? So my answer is in fact C. The next question is also an application of DeMorgan's law, but this one you're actually going to want to use a truth table for. Now, the reason you will want to do that is, one, because you see the expression, it asks what the expression evaluates to, but you don't have what X and Y are, right? You're not told that X equals true, Y equals true, or anything like that. So you have to look at all combinations of X and Y. You also know that you would want to use a truth table for this, because if you look at your answer choices, it's either going to be always true, always false, true only when not X is true, true only when not Y is true. And these answer choices suggest that there's going to be some sort of pattern to what the expression evaluates to. So you're going to want to use a truth table for it. Now, before you use a truth table, you always want to see if there's a way to simplify the expression. And using DeMorgan's law will simplify the expression for us. So I can simplify this expression piece right here, as well as this expression piece, because it has that not symbol in front of the parentheses there. So this expression will simplify to not X and not Y. And then this expression will simplify to Y or not X. Okay. And then once I have it down there, I can use this to evaluate. Now, remember that in order precedence, this evaluates first. Then this is going to evaluate, and then whatever that evaluates, then has the or not X with it. Okay, so I'll lay it out like that. So when you set up your truth table, that's the order that you want to set up the columns, right? You want to figure out X and Y in all combinations. You want to figure out what not X and not Y are. Then you want to figure out this expression, then this expression, then the full expression there. And that's how you want to build a truth table to be able to help you solve these complicated expressions. So that's what I built. Okay, and that's what I built in 9. So first I need to figure out what not X and not Y are in my truth table. So you can pause the video if you want to fill those values in. Next, I'm going to be focusing in on this expression right here. Okay, and that's what this first column is going to do. If I look at not X and not Y, I'm looking at these two columns. This is going to be false. This is false, and this is true, because I'm using the and to compare those two columns. Okay, so false, 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 true. Okay. All right, so that's that first column. Now I'm going to take that column and compare it to Y. Okay, because I just figured out what this column evaluates to, and I'm going to compare it to my Y column. Okay. And I'm going to compare them with the and symbol. Okay. So true and false evaluates to false. False and false evaluates to false. True and false evaluates to false. And false and true evaluates to false. Okay. I get falses all around. Okay. Now, if the problem ended there, this would be a good example of what you'd see when B was the answer, right? But the problem doesn't end there, okay? The problem ends, we have this last comparison. We're going to compare this column with or not X. So not X is this column right here. So we're going to compare these two columns with an or. So false or false is false. False or false is false. True or false is true. True or false is true. Okay? And then that's it. Okay? That's it. I'm done. But I have to choose my answer. Okay? And what are my answer choices? Well, it's not always true. It's not always false. Okay? So those are out. Next, what C and D are trying to say is compare the columns, right? So compare this column with your not X column and compare it to your not Y column. Okay. And do you notice a pattern? Well, I actually noticed this pattern right here, right? Notice how the not X and this column, they have the same result. Okay. That means that this expression is true only when not X is true. Okay. Expression is true only when not X is true. Okay. Not the same for the not Y. So that's why your answer here is going to be C. Okay. Whew. So that's pulling together a lot of concepts, which is why the AP exam really digs these types of problems. Okay. So you got DeMorgan's law, you got a truth table for logical comparisons, you got all of your Boolean operators. You have to be able to kind of organize those thoughts with a truth table in order to evaluate it. Okay. All right. Let's look at another popular one. Which of the following best describes the outcome of the Boolean expression? Again, notice how X and Y they don't have values to substitute in. So that means we're probably going to want to use a truth table. And then notice the choices. Always true, always false. True when X is true. False when X is false. So a truth table it is. Okay. I can use DeMorgan's law to simplify, so I'm going to do that. Okay. And then, again, build up your truth table. So I'm going to start with X and Y, and I need to use this. I need to use this as a column first. So I got to figure out what not Y is, compare the not Y column and the X column, and then compare that result with a not X. Okay. So I got to use all of those. So I'm going to figure out my not X and my not Y's. Then I'm going to do this one first. This is my first column. I'm going to compare my X's and my not Y columns. Okay. So if I compare those with the and, I get, I get false, true, false, false. Okay. False, true, false, false. I'm comparing those two columns. Okay. Now that I have that column, so this is the column I just evaluated, I'm going to compare it to the not X column. So I'm comparing this column and my not X column, and I'm doing it with the and, okay, with the ampersand. Okay. So the double ampersand, compare them. False and false is going to be false. False and true is false. True and false is false. True and false is false. So what's your pattern? Well, that's always false. That's an always false statement, no matter what the values of X and Y are. Okay. And again, it's not something you can just kind of look at and say, yeah, that's always false. Duh. No, you can't do that. You have to use a truth table, organize your Boolean values, and look at the different combinations there. Okay. All right. I have one more example. And then we're finally going to wrap up the lesson with our ending lesson here. So one more example, and then we're going to talk about comparing objects, and then we're done. Okay, it's been a long video. Thank you for sticking with me so far. I appreciate you. Let's do one example, and then we're going to finish with comparing objects. So in this example, which of the following best describes the outcome of the Boolean expression? Oh my gosh, another one. Here we go. A and B. Okay. Pause the video, try it on your own. Okay. See if you can get it. Maybe especially making that truth table. How can you build the truth table to help you solve this expression? Okay. First, I'm going to use DeMorgan's law, my favorite guy. Okay. So here, okay, is an example of when, so I overuse parentheses, which I love, right? So I have this parentheses here, and notice how this got distributed to both of these. Distributed. Remember how I said, hey, Goldie, you said not to think of it as distributive. Because of this, when you distribute in math class, you are taught this is the answer and the parentheses go away. Okay. That is in fact not true in Java. If you have this expression, when you distribute, the parentheses do not actually go away. Like you still have to figure this expression out before your other comparison operators. And that really trips up students because you're used to, once you distribute, the parentheses going away. But that's not the case because of the unary operator has that not only implied parentheses, it means you have to evaluate what's inside first. And when you're distributing, you're not evaluating what's inside, right? The parentheses, you have to evaluate what's inside first. And when you give the unary operator, you're not actually evaluating what's inside. So the parentheses are still there. Does that make sense? So luckily, I already had parentheses here just to kind of draw attention to this fact. If these parentheses were not here, if these red ones were not here, you would still need them, okay? You would still need them, all right? Do not get rid of them, all right? So really, you should have double parentheses here, okay? Do not get rid of them. Now, is this tested on the AP exam? I have not seen a specific example like this on released AP exams or any released multiple choice question. Okay, so are they going to test this? I don't know. I have no insights into that. I do not know what they put on the exam, but this is a fact. This is a Java fact. I want you to know this. Okay, this is why we don't distribute. Okay, off my soapbox. Anyway, what this means for you in terms of a truth table is that you have to figure out what this column is first, and then this column, and then lastly compare them with the and statement, okay? So here's what I got. I'm going to figure out not A, not B. I'm going to have a column that figures this out. I'm going to have a column that figures this out. Then my last one, I'm going to compare these two columns with that and. Okay. So that's how I set it up. Always set it up with a plan. Excuse me. Set it up with a plan. Once you set it up with a plan, then we can evaluate the truth table. So pause the video if you want to try filling out the truth table on your own. Press play when you're ready to see the answer. Because here's A and B. Ooh, sorry, that E option is not supposed to be. It's not supposed to be there. So here's not A, not B. Okay. Here is these two columns compared. Okay, so we're comparing those two columns with the or. So I get false, true, true, true. Next, to figure out this, I'm just comparing these two columns, B or A. I get true, 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 false. And lastly, to figure out the whole expression, I'm comparing these two columns with the and. So this is going to be false, true, true, false. Now we need to figure out which of the answer choices it's going to be. It's not always true. It's not always false. Okay, because I can see that clearly. Not always true, not always false. So is it true when A and B are different values? Okay, let's see. Or is it true when A and B are the same values? Okay, let's see. When is it true? This expression evaluates to true when A and B are different values. Do you see that there? Okay, so when A and B are different values, that's when that expression is going to evaluate to true. So all of these, a lot of different ways of asking not the same thing, but kind of solved the same way, right? With a truth table, probably using DeMorgan's law to simplify it, make it a little bit easier on yourself first, and then seeing what that outcome is. Okay. All right. I can see the light at the end of the tunnel. That is this lesson. Okay. We're going to finish this lesson talking about comparing objects. Okay. Now we use the equal to as a comparison operator to compare values, right? To compare, is 3 equal to 3? We want to use them to see if it's the same. Now that operator in Java, that operator compares contents of the boxes that those variables are referring to. So with primitives, remember we said primitives are like leftover containers, right? Where you have the container, the variables written on the container, and your data is stored in that container. So if you compare two primitives, then perfect. You're comparing the contents and to determine if they're the same, okay? So it works like this, right? They're the same, they're not the same, and it works as expected, basically. So if A equals B, they are the same, else not the same. So in this small code segment, you would print off same. Okay. Why? Because the boxes of both A and B hold the value of 20. Now, with class data types, however, which does include strings, we have to be careful because what's stored in a box is not the data. What's stored in the box is the memory location. Okay. It points to a location in memory. Okay. So I'm going to do a string example here. I'll do an object example in a moment. But with strings, remember, strings are class data types. They are not primitive. So string here, I have two ways of creating a string, A and B. C and D, because they are a class data type, you can also use a constructor to create a string, although it's not common. We don't usually use that. But that is another way to make a string, is with the constructor. Now with the equal to, what happens when you compare class data types is because they are not pointing to the memory addresses, they're pointing to the same, they're pointing to different locations in memory. They have different memory addresses, even though their contents are the same, because they're pointing to different spaces in memory, they are not going to evaluate to equal. Okay. So when you try to compare two strings, it doesn't work. Now I say that, and I'm going to show you the exact opposite of what I just said. Because if you try to compare A to B, notice A and B both have APCSA all caps, right? And I say A equals B. That actually prints true. And Goldie, you just told me that should print false. And I did, student. I am sorry, I lied. And the reason it prints true is because of this fancy thing called the string pool. And without getting into too much crazy detail, basically the string pool, it's an efficiency feature in Java that allows you to, if a string is already in use, it allows Java to look in the string pool. If you create a string like string A equals APCSA, that string is put in the string pool. And then when you create a string B, APCSA, when you create it like a primitive type, it looks in the string pool first and says, hey, if we're already using that string, let's save memory and let's use it again, and let's point to the same location again. And for that reason, the string pool is why A equal B will actually print true. Now, logically, you would think A equal C, because they both are APCSA, you would think those would print true as well. But it actually prints false, because A points to the location in the string pool, and C creates a brand new fancy schmancy string with its own location in memory pointing to its own data of APCSA. It does not use the string pool. So when you try to compare them, even though they have the same string, they have the same string of characters, they're pointing to different locations. And equal to, because it looks at what's stored in that reference variable. In the reference variable for strings, it's a memory location. And in both of these, they're pointing to different memory locations. So you are going to print false. Same thing with B equals C, and same thing with C equals D. Okay. Now, when we try to compare strings to see if two strings are equal to each other, we're not interested in memory locations, right? You don't have to know about the string pool. You don't have to know about that stuff, right? We don't care about that in this class right now. When you're trying to compare strings with the equal to, all you care about is, are the strings characters the same? And to use that, we use a built-in method called dot equals, and it compares class data types like strings. Now, strings has a built-in dot equals to method. You do not have to make it. It is already ready for you to use. So if you want to see if two references have the same characters, you'll use the dot equals to. So A dot equals to B will print true. A dot equals C, B dot equals C, and C dot equals D. They will all print true, okay? Now, even though we could do A equal B and it prints true because of the string pool, this is not good form, okay? I don't want to teach you bad form in this class, okay? Even if it's technically correct, I don't want to teach you bad form. Don't do that, okay? Do not do that to compare strings. Anytime you use the equal to with strings, a little Java fairy dies, okay? Don't kill the Java fairies. I need you to use the dot equals. This is the correct way to compare strings, okay? I'm losing my mind. This is a long video that I'm losing my mind thinking about Java fairies. But you're going to use A dot equals B to compare strings, okay? Do it. Trust me. Your code will thank you. All right, we're almost to the end. Comparing objects. This is my last thing I'll say, okay? To compare objects, we have, that we have created, we often have to create a dot equals method. And with strings, the dot equals method is already made. So just use it in your code and know that it works. When we have objects that we create, then we have to code a dot equals methods. And that's usually because when we're comparing objects, we want to check to see if their data is the same, right? Again, we don't care about memory locations. We don't care if they're pointing to the same spot in memory. We want to know, does the data match? Is their data the same? And we can make a dot equals method to do that. Now, we'll discuss how this is written later. This is going to be next unit. We talk about how it's written. But here's an example of what it looks like. So let's say we have a costume class with a single instance variable, and that it has a dot equals method that works as intended. Now, when you see this, it has a dot equals method that works as intended. The AP CSA exam will sometimes say those words as a form of testing you on data abstraction. Or procedural abstraction, where it gives you a method and it says, hey, use this method and know that it works as intended, know that it works correctly. Do you know how to use a procedure that you didn't write in your code? And it's a way of testing you, and they will test you on that. So here's the situation. Costume has a dot equals method that works as intended, meaning it has a equals method that compares instance variables content to see if they are equal. So if I have what is printed as the result of the following code, I have a costume myself equals new costume fairy princess. That's why fairies were on my mind. Okay, I'm not crazy. My friend equals new costume fairy princess. Now, when we construct these costumes, okay, myself and my friend, remember I construct the reference variables, myself, my friend, and those reference variables point to two different locations in memory where I construct my new costume, okay? So when I compare myself equals my friend, you're going to print false because these two point to different locations in memory. But logically, I want them to print true because, hey, myself and my friend have the same costume. We have the same data. We have the same, instant variable contents. I want that to print true. And that's when I use the dot equals method. So if I compare myself to my friend with the dot equals method, it will print true because we have the same instance variable content. Okay, does that make sense? Procedural abstraction. We're going to write the dot equals method in the next unit. Okay. Technically, it's not covered on the AP CSA exam anymore. Writing your own equals method is not covered on the CSA exam, but we're going to do it anyway. What is covered is procedural abstraction. Can you use a dot equals method that's already been written for you in the correct way? And this would be the correct way. Does it have the same contents? Okay. Oh my gosh, Goldie, stop talking. We are done. We are done with this set of notes. I know it was a long one. This is probably the longest video I've ever made. What a record. I love it. So I appreciate you sticking with me. Please like it because I put so much work into this. You put so much work into this watching this video. Like this video, subscribe to my channel for more great CSA content. Thank you for sticking with me. I promise the next videos aren't going to be as long. All right. Thank you guys again, and I will see you in the next video.